When solving for right triangles, do you ever wonder whether to use Pythagorean Theorem or trig functions? Keep watching because we are going to be finding out the difference in this week's Word Problem Wednesday. I'm your host, Latrell Jackson, and this week we're going to be helping Lorenzo find out how high his kite is and making some really cool height references when we're done. Keep watching. Welcome to week 3 of Word Problem Wednesday, and this week we're going to be answering the question, how high is Lorenzo's kite? We'll be using the 3-step word problem solving process. In step 1, we'll be using RRTR, where we'll be working on our reading comprehension. In step 2, we're going to be going on a scavenger hunt for 4 things. And then step 3 will be solving with strategy and purpose. So let's start with step 1. RRTR stands for read, reread, think, rewrite. Let's see what the question is by first reading it. All right, so it says Lorenzo is flying a kite and lets out 51 feet of string, which makes a 72-degree angle with the ground. Assuming the string is straight, how high is the kite? Okay, let's read it again. Reread and then think. Lorenzo is flying a kite and lets out 51 feet of string, which makes a 72-degree angle with the ground. Assuming the string is straight, how high is the kite? Let's think about this. So Lorenzo is flying a kite, right? He's flying a kite. What's a kite? A kite is diamond-shaped item, usually made of cloth, and it has a string that connects to the person who's holding it. There's a spool of string, so the string is being wound up, and the person who's holding the kite will unravel the string from the kite and let it out. That's what lets out means. So Lorenzo ended up letting out 51 feet worth of the string, and it made a 72-degree angle with the ground. So if we think of Lorenzo right here where my hands are touching, the kite is where my fingers are, and the ground is this hand. So here is the angle, right at the opening. That's the angle that the kite came up from the ground, or is up from the ground, 72 degrees, okay? It's probably like around this amount. All right, so we have kind of a little bit of a visual based on the fact that we thought about it. What's next? All right, so we're gonna rewrite this whole question, all right? What is included in rewriting? We have to replace the numbers with blank spaces. Rewrite in your own words, number 2. Number 3 is draw a picture or a diagram. And then 4 is to replace the numbers. So put the numbers back, okay? All right, so we took the numbers out. Actually, instead of blank spaces, I used pound signs or number signs so that you know that it's a number was there. Now let's work on writing our own question, writing it in our own words. What do we want to change? How does it sound? What will make it sound better and easier to understand as you're trying to figure out how to solve this problem? We use words like unravel, unraveling the string in place of let out, because that's a little bit more understandable and another way to say let out. Also, raise up from the ground. Oops. So the kite could be laying on the ground, but it's actually raised up in the sky right at my fingertips. So instead of makes a 72-degree angle with the ground, we can say it raises up 72 degrees from the ground. So think about it a little more and let me know in the comments how you would rewrite this question. I would love to see how you say it instead of the way it is said right now. What I'm going to do now is write out the question in my own words. So here is my version of the original question, and it says, Lorenzo is flying a kite and unravels several feet of string into the air. There is an angle between the kite and the ground with Lorenzo at the vertex or corner. If I assume that the string is pulled straight by the wind, how high is Lorenzo's kite? So let's just go back and just look at the revisions. I included unravels and included into the air. So unravels several feet of string into the air. That wasn't included in the original question. I included it so that we can see the string being carried away into the air by the wind as the kite gets higher into the air. Also, I expanded the angle portion and by saying there is an angle between the kite and the ground with Lorenzo at the vertex. So vertex is the corner of the angle, and that's another vocabulary word that you can include into your toolbox. And this sentence helps us to visualize the angle that's being created. And in the last part, I revised the whole thing, put you in the position as a spectator, or I, by saying I, if I assume that the string is pulled straight by the wind. By the wind, we want to remember that the kite is being pulled up into the air by the wind. If there was no wind, the kite would be on the ground. Usually people go out only when it is a windy day to fly a kite, so that the wind will go up. And then how high is Lorenzo's kite? So that revision, my purpose was to give it more of a visual so that we can proceed in properly solving the question. Okay, so we got kind of an idea of what it looks like in our mind's eye when we explained it. Wrote it in our own words. So let's actually draw a picture to match what we see. So here's Lorenzo. And he is happy because he got to go to the park and fly a kite. So let's draw his string. The string is straight, not diagonal or curvy. All right, that looks like a straight string. And let's draw his kite, orange. And these are the sticks that keep it in place and let the wind just float it all over the place. And we also want to draw the ground because that's kind of a key part of the problem is the ground. And let's draw a little invisible line in black from the top of the kite to the ground. It's going to be dotted because it's not really there. Okay, and so the kite, we drew lines from the top of the kite to the ground because we want to know how high the kite is, right? So we can call this the height of this or the length of this line h for height. Okay, h is for height. And we actually know the length of this string. We can't see it yet because we took the numbers out of our question, but I'm going to label this string S for the length of it, okay? Lastly, we have an angle, and remember the angle is created by the kite being raised up off the ground. Because remember, actually, it started out in Lorenzo's hand, and then he let it out into the wind, let the wind blow it out, and then he unraveled the string as it got higher and higher into the air. If the wind was not there, the kite would fall flat to the ground, right? So the wind is the thing that's keeping it up in the air, the kite. So the angle that's being created between the kite and the ground is right at Lorenzo. Lorenzo is the vertex of this angle. So we're going to put a little arc and call this theta, because theta in math usually represents an angle measurement, okay? So we call this theta. Theta is a Greek letter and it's usually used for angles. All right, do we have everything? So we have everything labeled, even if it's not labeled with a number, it's labeled with a variable so that we can later fill in the numbers and solve for the variable. I just thought of this. Let's add in a little bit of wind so that can help the kite to stay in the air and the string to stay straight. Okay, there we go. Okay, so here we have replaced the numbers. We put them back into the problem, and we actually put them back into our new word problem that sounds a little more pleasing to the ear, and it sounds easier for us to be able to visualize what is going on. So let's just read it again with the numbers replaced. It says, Lorenzo is flying a kite and unravels 51 feet of string into the air. There is a 72-degree angle between the kite and the ground, with Lorenzo at the vertex or the corner of the angle. If I assume that the string is pulled straight by the wind, how high is Lorenzo's kite? That sounds a lot more easier to answer because we have the numbers, we have the picture in our mind, and we can refer back to the picture if we need to, and we can start solving now. So now let's go on a scavenger hunt for these 4 important components of the problem that we're going to need to solve. So we're going to need numbers. We're going to need to know the unknowns or variables. We're going to need to find the hidden operations in the problem. And we're also going to need to find the separate parts, if there are any, to solve in this problem. First, numbers. That was easy. We just replaced our numbers. We know that 51 feet is the length of the string that was unraveled by Lorenzo into the air, and 72 degrees is the measure of the angle that the kite is being created between the kite and the ground, with Lorenzo at the vertex. Next is unknowns or variables. So the only thing we don't know is how high Lorenzo's kite is. That's what we're trying to find out, and that is also the unknown. Operations. So what is the operation we're going to be using? Well, the operation that we're going to be using is embedded into this highlighted sentence in green. It says a 72-degree angle between the kite and the ground, with Lorenzo at the vertex. So the angle, the information about the angle is what we're going to need to figure out what operation we need to use. So it's in that portion right there. Okay, and then separate parts. So how many parts are there to solving this problem? There's only one part, and that's just finding out how high Lorenzo's kite is. We don't need to solve a whole bunch of other steps, take a whole bunch of other steps in order to solve this problem. We just need to do one thing. And we're going to find out what that one thing is in 1 second. All right, so we found all the components to the problem that we need to solve it. Are you ready to solve? If you are ready, put ready in the comments below and we're going to get to solving. All right, so we got a strategy, got to solve with strategy and purpose. We need to know what we're doing before we start, and then we need to make sure that when we're solving, we're doing it for a reason, okay? And that's to get the answer. So number one, we want to be sure to outline a strategy. Then we want to, number two, label our values and numbers. We want to three, double check the question to make sure we answered it. And then four, we want to circle and box our answers, okay? So here's the dilemma. We have a right triangle. So if you can remember, here is a triangle that was being made between Lorenzo, the kite, and the ground. So this was the string in gray, and the ground was green because it's grass. And then the height was invisible. So it was a dotted line going straight down from the kite, okay? So here's the thing. When a line is being shot straight down to a flat line like this, then that means that it is creating a right angle. And the right angle is right here at this corner, okay? So this right angle was created because we're looking at the kite and we're dropping a line straight down to the ground. And since that's the case, that makes this triangle a right triangle. Okay, so we got that. This is a right triangle. So what I wrote here is, since we see a triangle in the picture, it's possible we'll be using either trigonometric ratios or Pythagorean theorem. Which one will we be using? And these two are only used when we are talking about a right. So what's the difference between Pythagorean theorem and trig ratios? As we see here, the Pythagorean theorem measures sides of a right triangle only. So as we look at this diagram, it has A, B, and C. Those are labeling only the sides. And then the formula for the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so what about trig ratios? Trig ratios measure the sides and angles of a right triangle. So we have the angle right here labeled theta, the side that is adjacent to the angle, we have the side that is opposite the angle, and the hypotenuse. Okay, so which one are we going to use today? Well, since we are given the measure of a side and an angle of a right triangle, then this is a trigonometry question, and we must use sine, cosine, or tangent ratios to solve, okay? So we have an angle, and we have a side. We have an angle, the measurement of the angle, and we have the measurement of the hypotenuse. So we're going to be using one of these trig functions. Now we need to figure out which one. So the first thing we're going to do, we're mapping out our strategy now. We're going to draw and label the right triangle with the numbers this time instead of just the variables. Then we're going to determine which trig function to use, whether sine, cosine, or tangent. So let's draw our triangle, remembering that it is a right angle. And let us label. Okay, so S was the length of the string, and the length of the string is 51 feet. Lorenzo is flying a kite and unravels 51 feet of the string into the air. So this side is 51 feet. Then we have H. Do we know what H is? H is the height. Height is what we're trying to find out, right? It says at the bottom, if I assume that the string is pulled straight by the wind, how high is Lorenzo's kite? So that's the question, how high? So let's put a question mark here. And another thing we know is the angle. So there is a 72-degree angle between the kite and the ground with Lorenzo at the vertex. So this angle is actually 72 degrees, okay? All right, so we have our triangle. It's all labeled up. Now what do? We need to identify which one of the sine, cosine, or tangent ratios we use. Now, when we're dealing with trig functions, we have important words we need to use and remember, okay? So, given that the angle is right here, everything is centered around this one angle. So, the side that is next to the angle is called adjacent. The side that is across from the angle is opposite. And the other leg of the triangle would actually be directly across from the right angle, and this is called the hypotenuse. Okay, so these are important sides that are going to be used in our trig ratios, and I'm not sure if you have learned SOHCAHTOA. This acronym helps us to remember what our trig ratios are. So for the first letter of each of these words, they stand for the trig function. So for S, that would give us sine theta, okay? So sine theta, and then the next two letters would be the ratio or the fraction that is being created. So this would be opposite over hypotenuse. And as you look back at the right triangle model, you can see here's opposite and here's hypotenuse, okay? So the next one is CAH, C-A-H. And remember, the first letter stands for the trig function. So this one is actually going to be cosine. And the next two letters are AH, or adjacent over hypotenuse. Adjacent over hypotenuse, okay? So here's adjacent, here's hypotenuse. Last is TOA. So the first letter stands for tangent, the tangent function, and OA would be opposite over adjacent. That's what those letters stand for. And if you look at the triangle, we got opposite and we got adjacent right here, okay? So these are our trig ratios, and we need to pick one out of the three in order to apply to our situation. How are we going to find that out? Well, we need to look at our situation. So what do we have and what do we need to find? So we have the angle, we have the measure of the string, which is the hypotenuse, and we actually are looking for the measure of the height, which is the opposite of the angle, okay? So we have opposite and we have hypotenuse. Cool. Which one of these trig functions include opposite and hypotenuse? I think I found it. It's the sine trig ratio. So let's plug in and see what we can do. Okay, so we have sine theta equals opposite over hypotenuse, right? And let's start filling stuff in. So we know theta represents the angle, and the angle is 7. And then when we're looking at the ratio, opposite is in the numerator. What's opposite? We know that opposite actually represents the height of this kite, but we don't know what the height is. So we're going to call height x, okay? And then what's in the denominator is hypotenuse. Hypotenuse we know actually represents 51 feet. So we're going to write 51 feet in the denominator. Okay, cool. Now, what do? We have a fraction on one side of the equation, and we have a number. This is going to reduce to a number on, or a whole number, not a whole number, but a non-fraction on the other side of the equation. How about we change this non-fraction to a fraction, okay? We can do that by writing it over 1, like this, equal to x over 51. Why did I do that? This is so that we can do cross multiplication. Cross multiplication is one method of solving an equation when you're able to do so, when you have ratios or when you have a proportion. So we cross multiply x times 1. What's x times 1? We're going to go up here. X times 1 is x, and sine 72 times 51 is, we're going to write it again here. Sine of 72 times 51, okay? Now, I wrote it like that because when we do sine of 72, we're going to get a long irrational decimal number. And we don't want to round it. We want to keep it that length until we get to the final answer, okay? So we're going to just plug in 51 times sine of 72 degrees, and then whatever that answer is, then we'll round it, okay? So let's go over to Desmos and plug this into the calculator. Okay, so we're going to type in our problem, which is 51 times sine of 72 degrees. And we see the answer right here. It's 48.5. I'm going to round it to the nearest tenth. Okay, so this was our original problem. We went to Desmos and typed it out in the calculator, and we got 48.5 rounded to the nearest tenth. What does this 48.5 represent? Well, if you remember, our x represented the height of the kite from the ground. So our height is actually 48.5 feet. And that's our answer. So let us circle or box and just check if we answered the question completely. So the question says, how high is Lorenzo's kite? We got a height. We got 48.5 feet high. And we're done. Now, let's do a little bit of height reference. Like, how high is 48.5 feet actually? How does that look? So 48.5 feet tall is actually a US telephone pole, which is standard 40 feet tall, plus the tallest man on earth, which is Mr. Sultan Kosin, 8 feet and 1 inch tall, standing on top of that telephone pole. So the kite is just a tad bit higher than this. So if you like this video, please give it a thumbs up. If you were able to understand it, please let me know in the comments that it went well. If not, please let me know too where I can improve. Also, let me know in the comments what algebra topics you would like me to do a word problem on for future Word Problem Wednesdays. I'd love to see what you are interested in. Also, make sure you subscribe and tap the bell next to the button so that you will be instantly notified when I upload my Word Problem Wednesday. Also, if you can benefit from some math tutorials, study guides, cheat sheets, please join the KOG Math Success Library as a free member, and you'll be able to access all those things to help you along your math journey. I would love to see you in the library. All right, thanks so much. See you next Wednesday.